Hi everyone. I wanted to go over some review questions and just some key concepts that you need to know for the Regents. So I'm going to hit one of each of these um, and just go over some skills that you need to know in general about test taking. So this is the document that I sent you that was called Regents Predictions Packet. I did it on the last Regents review, which was last week on Wednesday. And basically, it's just going to go over everything that I think is definitely on the Regents and then some predictions about what I think will be in some form on the Regents. All right, so here we go. So definitely on the Regents. The first thing is the average rate of change. They love asking about average rate of change. And lately what they're doing is giving you a function that may be kind of complicated looking, and they ask you to do the average rate of change over a given interval. So the first thing you need to be aware of is the equation they give you, f of x, or whatever it is called. You're going to want to put this in y equals, all right? Then once you put that in the calculator in y equals, you want to make sure you are in radian mode. And again, I do believe that you should be in radian mode for this entire Regents. That's my advice. So once you put this in y equals, then what you're going to do is you're going to look at the table at specifically the x values that are in this restricted domain. So this is called a restricted domain. And it's asking you to look from x equals -7 to x equals 7. And specifically do the rate of change of from -7 to 7. Okay, so you need to know the formula for rate of change is change in y over change in x, which is y2 minus y1 over x2 minus x1. Remember, this is going to find the average rate of change over the given interval. So once you look at your table from -7 to 7, I recommend that you copy down the y values that correspond to those x values here and write them down. And then you're going to do change in y over change in x, okay? So change in y, whatever that is in the calculator, and then the change in x, you're going to do 7 minus -7, okay? So once you do that and you get your answer, just make sure you have the change in y on the top of the fraction over change in x. And then you'll get your answer, and make sure you round appropriately. So another tip I have is eventually you're going to go back and check your Regents, and you really want to go back and look at anything that is in italics. That's going to specifically be all the rounding. So make sure that you go back and round. So nearest hundredth is 2 decimal places. So make sure you know how to round, and specifically in this case to 2 decimal places. So I did put this in the calculator and I wrote down a few decimal places. And another tip of advice would be just to write down more than one decimal place, because you don't really want to round until the very, very last step. So I wrote down 3.3636 and -0.297. And then when I subtracted at the end, I had to eventually round to the nearest hundredth. So then I got choice 3. So again, don't round till the very, very end, last step. Now up ahead, you see 2 more questions related to average rate of change. We have different functions. We have another sign function. I'm sorry, one other question. All right, let's move on to something else that definitely is going to be on the Regents, and that is going to be normal probability. So they're going to ask you for the probability, which is going to be the area under a bell curve. So if they say the data is normally distributed or approximately normally distributed, I want you to underline that and tell yourself this means that this is a bell curve question. This is probably going to be either a 2-pointer multiple choice or it's going to be a 2-pointer free response, but it's not really more than 2 points, okay? So keep that in mind. So if you see normally distributed, right away, draw that bell curve, draw a line in the middle, and in the middle put the mean, which is called mu. And also on the side, write the mean and the standard deviation, which are going to be given to you in the question. So as you can see here, I highlighted the mean, which is 1450, and the standard deviation, which is, so the mean was 1450, the standard deviation was 8.5. So in the middle, I'm going to put my mean 1450. Now, some of you are going to you're going to be resistant to drawing the bell curve. Please draw the bell curve. It's really helpful because a lot of you are just trying to do this in your head. And the problem is that sometimes you're not visualizing the correct lower bound and upper bound of your area. So this says, what is the probability, which means the area under the curve that the lifespan is between 1440 and 1465 hours. So 1440 is a number on the left of the mean, and 1465 is a number on the right of the mean. And it doesn't necessarily have to be symmetric, but what you want to do is shade the area that you're interested in finding, okay? Once you do that, then on the side, you want to write down the lower bound, which is the left bound of your area, and the upper bound, which is the right bound of your area, and the mean and the standard deviation, okay? So the lower bound was 1440, the upper bound was 1465. So left to right, left to right, left to right, low to high. The mean was 1450 and the standard deviation was 8.5. Once you write all that down, then you're going to press normal CDF. To get there, you're going to press second vars, and you're going to go to number 2, which is normal CDF. Make sure you don't go to number 1, which is normal PDF. We only use number 2, normal CDF. And then you're going to type in all this information that we wrote here, and you're going to write your answer. The answer that I got for the normal probability for this one was choice 3, which was 0.8415. So that means the area under the bell curve is 0.8415, or 84.15% of the time the lifespan of the light bulb is going to be between 1440 and 1465. If you ever see notation for this, the notation is 1440 less than x less than 1465. And a P on the outside means probability. And this is something we use when we get to AP statistics. Now, when you look at the next question, I just want to let you know that for these questions, you have to look and see if it says between, which is the one that we just went over from left to right. That's kind of easier to enter. Or if it says something like more than, or less than, or at least, or at most, because that's going to signify that you're going to either shade to the right of the area or to the left area. So keep in mind, this one says more than 4. So when I shade the area, it's going to be slightly different than the last question. All right, so notice again, it says normally distributed. Does it say normally distributed? Yeah, here it is, boom. So draw the bell curve, in the middle put your mean, 3.39. On the side, also write your standard deviation, 0.55. We want more than 4, so that's going to be the probability. X is more than 4. 4 is to the right, so put a line to the right, label it 4, and then shade to the right. Now, because this is a free response, we have to show a little bit more work than if it were multiple choice. So get in the habit of drawing the bell curve, putting the mean in the middle, labeling everything, shading the area that you're interested in. So for this question, the lower bound is 4, which is the left boundary of our area here, 4. And then the upper boundary is infinity. But because we don't have an infinity button on our calculator, we're going to use a really big number. We could either type in 1 million, or we could type in 1 times 10 to the 99 power, which is 1 EE99. So remember, when you're reading this from left to right, the left bound is the lower bound, and then the upper bound, if it's to the right, it means it's going out forever. So just put in a really big number for the upper bound, okay? So when you hit this second var, same thing, number 2, normal CDF, put in the lower bound, the upper bound, the mean, the standard deviation, and you're going to get an answer for your probability. But please note, if they don't ask you for a probability like number 1, which above they asked for a probability, here they said how many. So if they ever ask you how many of whatever it is, then you have to take the probability, whatever that is, and you have to multiply it by the total amount in the question. Okay, so once we do second vars, normal CDF, lower bound, upper bound, mu sigma, you're going to get a probability. Whatever you get, you're going to multiply that by the total in the sample, which is 9256, and then that's going to be the amount. So this time we want an amount, not a percent or a probability. So just be aware, again, when you're reading your Regents toward the end, like read each question and say to yourself, did I answer the question? Did they ask me for probability? Did they ask me for amount? Did they ask me for percent? Did they ask me to round to the nearest percent? What did they ask me for? So when I did this normal CDF, I ended up getting I got, a long number for the probability. I got specifically 0.133, not 695, whatever, okay? So some people ask me, like, do I have to write that whole thing out? I would write it out or put a little dot, dot, dot. And in the calculator, I would not round it. I would just leave exactly what you got from your last answer from the normal CDF on that line. And then I would just hit up, enter, reselect the last answer, and then multiply that by the 9256, and then round at the very end, the last step, to the nearest integer. So when you do that, you end up getting 1237-ish babies. So that is the final answer. Okay, so just a tip, note to self. If it says between, you're going left bound, right bound, and it's pretty straightforward. If it says more than or less than, you're going to put in either positive infinity or negative infinity for the upper or lower bound. And if it says a percent or probability, your answer is going to be a decimal like this. But if it says how many, you have to take your probability and then multiply it at the end. So I want you guys to try number 3 on your own, but just note that this one says less than. So you know with less than, the lower bound is going to be the negative infinity. Okay, and the upper bound is going to be, in this case, 4.27. So that's my hint to you, is lower bound negative infinity with negative really big number, upper boundary 4.27, and then do the math. All right, so the next big topic that's always on the Regents is a 95% confidence interval. So when you're doing a 95% confidence interval, I want you to note that you need to memorize a formula for a 95% confidence interval, or understand the concept of 95% confidence with respect to the bell curve. So we just went over the bell curve. The bell curve follows this empirical rule, which is the 68, 95, 99.7 rule. And basically what that says is about 95% of the data lies within 2 standard deviations of the mean. About 68% lies within 1 standard deviation of the mean. About 95% of the data lies within 2 standard deviations of the mean. About 99.7% of the data lies within 3 standard deviations of the mean. So specifically what we care about here is the 95% level. If they ask you to do a 95% interval, which they will, then you have to know that you're doing 2 standard deviations above and below the mean, okay? So I would write that formula here on the top. I would star it. I would memorize it. It is not on the reference sheet. So to get your confidence interval, which I'm writing CI, you're going to do mean plus or minus 2 standard deviations, all right? Now, whatever comes after that plus minus is called the margin of error. So I just want you to know that if they just asked you for the margin of error, you would just do this piece here, which is the 2 times the standard deviation. All right, they might ask you that instead. So this question, they give you some information and then they tell you the mean and the standard deviation. Sometimes they write it, this is called a simulation here. Sometimes they write it on the top left in a little box, the mean, standard deviation. And sometimes they just write it in the question like they did down here, but just keep an eye out if you see a little box, like a little number here that says mean and standard deviation in this corner, that might be where you have to look for the mean and standard deviation. So all you have to do is this formula up top, do the mean plus or minus 2 standard deviations to get your 95% interval. And because it says the middle 95% of the data, I just want to remind you that it's because if you're doing a bell curve, the bell curve is centered around the mean. So if you went only 1 standard deviation above and below the mean, that would be the middle 68% of the data. And if you were to go 2 standard deviations above and below the mean, then that would be the middle 95% of the data. So when they're saying the middle 95%, they mean most people are located here, 2 standard deviations above or 2 standard deviations below the mean. We're getting an interval. And these people are the ones that are likely or plausible to happen just by chance alone. All right, so let's set it up. Here we go. We're going to do mean plus or minus 2 standard deviations. Okay, so you're going to do 0.254 plus or minus 2 times 0.060. Put it right in the calculator, do 1 plus, do 1 minus, hit enter, and see what you get. So when I did this, I ended up getting an answer of choice 2. All right. So let's say this is talking about the company. Let's say it was like an M&M's or something like that, is claiming that 24% of the candies in their bags are royal. Okay, this is their claim. So they ran a simulation based on this claim, based on the premise that indeed there was 24% who were blue, okay? So now they might ask you something like this as a subsequent question if this were a 4-pointer. Mrs. Burke opened up a bag of M&Ms and she got 10% blue, okay? So I got 10% blue in actuality. They're claiming that 24% of their candies are blue. But remember, there's a plausible interval created around it that we got in this question. We got an interval of 0.134 to 0.374. So it is plausible that just by chance alone, we can get from about 13.4% blue to 37.4% blue, okay? 13.4% blue to about 37.4% blue. So this little region should be the middle 95% of the data, okay? These are the things that are plausible or likely to happen by chance. So let's say I get 10% blue, okay? That number is not in the interval that was created around the things that were likely to happen based on that claim. So they might say something like, is it likely that I would get 10% blue? And you would say, no, it's not likely because that number 10% or 0.10 lies outside of that 95% confidence interval. It lies in that outer 5%, which is the lower 2.5% and the upper 2.5%. So if it lies outside the interval, it's rare that your findings happen by chance. And so if it happened, it may actually contradict what the company says, which is sometimes what they ask you. Right now, what you need to know is this. If 10% is not in the interval, it is unlikely to happen, and it actually contradicts the advertisement that they said. So now this next question is an example of one that they made into a longer part 2. So they said Joette's playing a carnival game. She's spinning a spinner. The spinner has 5 equal sized regents, so keep that in mind here. So each one, spinning each one should be equally likely. So Joette is claiming that the game is unfair because she only got her favorite number of 2 one time out of 10 game plays. So what she actually got 1 out of 10 twos, which is 0.1 twos. Okay, so 10% twos. But theoretically, there's a 1 in 5 chance of getting a 2. So that's 0.20 or 20%. So theoretically, she should have gotten 2 out of 10 twos, but she only got 1 out of 10 twos, okay? So she's accusing the game to be unfair. So is her result, could it have happened just by chance? Meaning like it was likely that it just happened by chance, or did it actually happen for the reason that indeed the game was unfair? So now they do a simulation and they want to know, is the game unfair or not based on her result? So what you would do is, because they didn't give you the information for the mean and the standard deviation like we did above, what you have to know is if this is, in this case, it's a nice number. There's 100 dots total in this dot plot. It's called the dot plot. The middle 95% of dots would be the middle 95 dots because 95 out of 100 is 95 dots. So basically, like the middle 95% would be somewhere here, and that is what is likely to happen by chance. And then the outside would be 5 dots, and 5 dots would be these 4, and then 2 more over here, okay? So her result that she got, Joette got 10%. Sorry, I spelled that wrong. Joette got 10% twos. Is that in the middle 95%? So the middle 95% is this middle 95 dots-ish, right? Is that result that she got in that middle area? It is. So if it is in the middle area, then actually what she got could have happened just by chance. So if it happened by chance, then the game's not unfair because this just could have happened by chance, not because it's unfair. So we want to actually say that here. We want to say Joette's result of 10% twos is in or within the middle 95% of the data. So if it's just in the middle chunk, you need to know it's likely. And if it's in the outside, it's rare. Okay. So if it's likely that it happened by chance, then it's not confirming that this game is unfair. So we say, thus, it was likely to occur by chance. And it doesn't confirm that the game is unfair. Now, let's say Joette had gotten 0 twos. That would have landed outside the middle 95%, although it's kind of confusing because there's some dots that would go either way here. But if it was maybe, well, let's go with 50% twos. So like half of her 10 spins were twos. That would have been in that outside region. So that would have been like unlikely that happened by chance. So maybe that spinner was rigged. So it would have been unfair. Now, so sorry, I didn't realize I didn't pause the video. So I ended up doing that and I ended up getting choice 2. Okay. All right. Next one. The probability Jane and Gary have a child is 0.25 and the probability of blonde hair is 0.5. What's the probability? The probability they have blue eye and blonde hair is 0.125. All right. So first of all, they gave you the and. So I want you to circle that and I want you to write down blue and blonde. Intersection of blue and blonde is 0.125. So there is an intersection between blue and blonde. So it is possible that you could have both blue eyes and blonde hair at the same time. If there is an intersection, that means that the events are not mutually exclusive, because mutually exclusive means no intersection, which means they both can't happen at the same time. That would be a situation like this, where the two events do not overlap. That is mutually exclusive events. So that would be like you're in 10th grade or you're in 12th grade. You can't be in both 10th grade or 12th grade. So the events are mutually exclusive. In this case, they told you that indeed you can have both blue eyes and blonde hair. So since both of those things can happen at the same time and there's an intersection, they are not mutually exclusive. These are not mutually exclusive, okay? So that's why it's not choice 3. So I would eliminate anything with the 3. So next we want to see, are they independent or dependent? So it looks like, again, we have the and. So remember, if we have the and, we're going to use the probability of A times probability of B and see if it equals the probability of A and B. So check it out. If you were to do 0.25 times 0.5, do we get 0.125? If it's true, they're independent. The last independence you might see is if they give you a two-way table like this and they ask you to show that the events are independent or not. If they just said gender independent of music style and they didn't specifically say female and rap, you could pick any gender and any music style. So they specifically said female and rap. So I'm going to use female and rap, but let's say they just said, are the two variables gender and preferred music style independent or not? Then you could pick anything. You could pick male and techno, whatever, but just define whatever you're doing for the person, okay? So if they don't tell you which way to go with this, you can use whichever rule works for you. So if you're someone who likes the and rule, you're going to do the rule of probability of female times probability of rap equals probability of female and rap, okay? And I like to put a question mark over the equal sign and either prove they're equal or prove they're not. Now remember, P means probability. Probability is a fraction. You need a denominator. The denominator is going to be the total in the sample, unless they give you a given that. So because they don't have any totals here, what you need to do first is put in the totals on the bottom row and column and get the total. And whatever is on this bottom right total, which should be 200 because they said 200, that's what your probabilities are going to be out of. So on our test, some people messed up because they didn't put a total. So make sure you do whatever the female total is out of 200 and the rap total out of 200. And then the intersection of female and rap, 25 out of 200, okay? So if I were doing this one, I would do female total right here, put it right here, forget this one. Then I would do rap total, 65, put it here, multiply these and see if it equals this. And if it is, if they're equal, they're independent. If they're equal, they're independent. It proves independence. If they're not equal, they're not independent. Now, if you're someone who uses the other rule, it would be the probability of A given B equals probability of A. I don't recommend this rule because I think some of you mix up the order of this. But if you did do that rule, I would say probability of female given rap equals probability of just female. Meaning, if they're independent, the probability of, if I told you that someone is a rap lover, it will not affect the probability that they're a male or female, meaning there's no relationship between your gender and your preferred music style. Now, just using common sense, I know that the gender and the music style probably do have a relationship. Maybe more females are likely to like country than males, something like that. So if there is a relationship between them, they should not be independent. So just remember, if they ever ask you a yes or no question on the Regents, like are they independent or not, you have to answer yes, they're independent, or no, they're not independent. And then if they say explain, you would write a sentence. But this says justify. So you just do the math behind it, the math of either one of these rules, and then show the numbers are equal or show they're not equal. And if they're not equal, you write not independent. And if they're equal, you write independent. Okay? So I ended up not getting, not equal. I ended up not getting that they were equal. They're not equal. I got 0.172 on this side and 0.125 on that side. So if they're close but not equal, they're still not independent. They have to be exactly equal on both sides. So keep that in mind. If I had done this other rule here, I would have shown also that they're not independent because I would have gotten out of the rap total, which is 65. The probability of female is 25. So 25 over 65 would have been 0.3846. And that wouldn't have been equal to the female probability, which is 106 over 200. That would have been 0.53. So these two are not equal, not independent. So again, I answer the question, yes, they're independent, or no, they're not independent. So no, they're not independent. They have a relationship, so they're dependent on each other. And the justification is the math. Okay, so please, I think this is one of the most important things to study if you are not good at independence. Study it. I would pick the easier rule, which is the and rule, and I would really just make sure you know that it's going to come up. The next topic that's definitely going to come up on the Regents is geometric series. I know I wrote on it, but it's Roman numeral 5. Geometric series is a formula on the reference sheet. So I would write down reference sheet. Specifically, it's the S sub n formula. So all you have to do is look at the formula on the reference sheet for geometric series. Series is going to be the sum of the sequence. So a sequence, again, is a list of numbers that have a pattern, and the sum of all these is going to be the series. So specifically here, they tell you there's 20 terms. So that's going to be that's going to be the n, 20 total terms. The first term is -2, that's called A1. And then you have to figure out the pattern here and find the common ratio. So remember, this is geometric, so you're going to be multiplying from term to term. So if you don't know how to get the common ratio, my tip is take any term and divide by the previous term. All right, so let's take the second term, 6. If you were to divide 6 by -2, you will get -3. If you were to take -18 divided by 6, you should get the same common ratio, -3. If you were to get 54 divided by -18, you'll still get -3. So the common ratio is -3. So basically then you're just going to go to your reference sheet. You're going to copy down the A1 minus A1 times R to the N, 1 minus R, and just substitute in the numbers and you'll get your answer. Plug this straight into the calculator exactly how it is with the numbers plugged in, and then you're going to get your exact value. And you know what? It's going to be a really big number for this one. Now, you may see this in the form of a word problem. If you see it as a word problem, they might give you a percent. The percent is going to have to do with the growth rate or the decay rate. In this question, Rowan was running a race, and every week he was running more than the week before. So this is called exponential growth. Remember, exponentials have to do with geometric sequences. So this is going to be exponential growth, and this is very commonly on your Regents. Exponential functions, geometric series, right? So the rate is 3%, which is 0.03, but the common ratio is not 0.03 because you have to remember that to get the base for an exponential, you have to do 1 plus the rate if it's growing or 1 minus the rate if it's decaying. In this case, it's growing, so you're going to do 1 plus 0.03, which is 1.03, and that's going to be the R that goes in this formula up here. Remember the R? So just keep that in mind because that's an error people made on their last test. So the first week he ran 15 miles, and then every subsequent week he ran a little bit more. So his common ratio is 1.03, and specifically we are interested in 10 total weeks. So you would do the S sub n formula, same exact formula as above, just copy it down from the reference sheet, and then you would just plug in these numbers here and get your answer. And then make sure at the end you round to the nearest thousandth. So remember, there's no shame in counting on your fingers. Tenths, hundredths, thousandths is 3 decimal places. So at the end, go back and make sure you round it appropriately. Now, the next skill that is definitely on your Regents, and it may be more than one question. You may have a multiple choice, and then you may also have a free response. The multiple choice might be something to do with the remainder theorem, and then the free response is going to be like a full question that you may have to divide, okay? So the first couple, you could either use the legit way for dividing, or you could just jump to the remainder theorem, which is a nice shortcut. So let's start with the remainder theorem. Remainder theorem is when you take your denominator, which is called your divisor, and you set it equal to 0. Then you solve for x. The x value you get is called a 0, okay? If, when you plug in the number into the numerator of your fraction, you get 0, okay? So if we were to plug in -2 into the numerator of this fraction, will we get 0? If you put it in your calculator, the quickest nice trick is put this numerator into y equals, and then go to the table to the value that you solved for, which is -2. And look at what's next to the -2. Whatever is next to the -2 is going to be the remainder if I had done a full division. Okay, so if there's a 0 next to that -2, then the remainder is 0, and that means that this thing, x plus 2, is indeed a factor. But if there's a number that's not 0 next to it, then this means that there is a remainder other than 0, and that means that x plus 2 is not a factor. So go to y equals, put this in y1, and then go to the table at -2, and then look for what it says next to it. Or plug in -2 into this top equation and see what you get. But make sure you use parentheses if you do it that way. So when I use the remainder theorem shortcut, I got a 2 next to the -2. This indicates the remainder is 2, which means that the answer is choice 1, the only one that has a 2 in the little remainder slot. So you're looking here, 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 and here with the sign as well. And the remainder is 2. Thus, the answer is choice 1. And the quotient would have been this. So for the next one, If you use the remainder theorem, I recommend it because it's easy. You're just going to set x minus 2 equal to 0, solve for x, you get 2, and plug in 2 into the numerator and see what you get. Now, if you were to do this using division or synthetic division specifically, I want to show you that you would have some spaceholders. So I want to make a note that you would use the coefficients of each term. So you would have 1x cubed, you have no x squared, so you have a placeholder there. You have no x, and then you have negative 2. So if you do it using this method where you put the 2 on the shelf, just remember that you're going to have a few placeholders because it jumps from the cube to the constant, so there are 2 placeholders. Now, if you would like, we will review synthetic. So coefficients are the numbers that go inside this little box. The number on the shelf is the number that we solve for if we were doing the remainder theorem. It's the opposite sign of what's in the denominator, which is the divisor. So you bring down the first term like this, and then you multiply this times this. So 2 times 1 is 2. Now you add. 0 plus 2 is 2. Now you multiply. 2 times 2 is 4. Now you add. Now you multiply. And now you add. So notice I'm going to get a remainder of 6. If I had done the remainder theorem and I had plugged in 2 into the numerator here, 2 to the third minus 2, I will get 6. If I had put this in y equals and looked on the table at 2, it would say next to it 6. This means that 2 is not a 0 because it does not have a remainder of 0 when you divide x minus 2. This means x minus 2 is not a factor because there is a remainder, specifically of 6. So the answer is choice 2. Now this brings us to 3. This is a full division question. So you can use remainder theorem to check to get your remainder to start if you like. If you do that, you're going to set x minus 4 equal to 0. Solve for x. You get x equals 4. Plug in the 4 or put this in y equals. And look on the table at 4 and see what's next to it to get the remainder. But because this wants you to do the full division and really get the quotient, you should really do the full division. So lately, I'm noticing some kids are having trouble with the tabular division, so I kind of am moving more and more towards synthetic. So remember, you're going to get your coefficients, you're going to put them in the box, you're going to put your number on the shelf, which is 4, and then you just have to make sure you remember the pattern to bring down the number, multiply, add, multiply, add, multiply, add, and then you're going to write your answer in this format where the quotient comes first, and then you put the remainder on the top divided by the divisor. Next thing you might see on the Regents is they might use the word equivalent. So regardless of if the question is about a quadratic, if the question is about an exponential, you have the calculator trick, which is the y1, y2, okay? So you would put this equation in y1, because it's a multiple choice, you can do this, and then you would put all the choices in y2, and you would see which one graphs on top of itself. So the tables would have to match in y1, y2, match, or the graph, when you hit graph, the graphs go on top of themselves. Okay, so that is the key for these. Now, could you do this the full out way? For sure. And if you want, you can. You can sit there and do x plus 2 times x plus 2, use box method. Then you can distribute the 5, but you have to remember to distribute the negative. And then you got to do all these out and see which one matches. And because you have 3 hours on your Regents, you can do it this way as well. The other thing I want to mention that you could do is you could pick a value for x. Let x equal 3, for example. Plug in that number into this whole thing and see what you get and write it down, and then do the same thing for all the choices and see which one matches. Same thing with number 2, we can do the same thing. If you want to know how to do it the right way, this is the laws of exponents. Remember, when we divide, we subtract exponents. So I would do 1/5 minus 1/2. I would literally just put this in the calculator instead of trying to get a common denominator in your head. Get your answer when you do 1/5 minus 1/2, and you end up getting negative 3/10, by the way. And then you would have to remember that a negative exponent means do the reciprocal of the base. So it was x over 1, it becomes 1 over x. then you change the sign. And then if you ever see a fractional exponent, you're going to do power over root. So remember, the power goes on the base, and then the number that goes in the root is called the index. It goes on the outside. The answer to this one was choice. You know you're going to get one of these. It's a rational equation. It's going to be in the form of multiple choice, most likely, and I don't recommend you do this by hand at all. Just put this in y1, the left-hand side of the equation, put this in y2, and look for the intersection. Now, before you do anything, I want to mention a little common sense here is you have to remember that any value that makes the denominator undefined is called an excluded value. So that value in this case is x equals 0. If x equals 0, the denominators would be undefined. So x cannot be 0. So I'm going to cross out choice 4 and choice 2 because they both have a 0 in them. So that eliminates some work for you. So now you go to y1, y2, look for the intersection on your calculator. To do that, you would hit second trace intersection. But another idea you could do is look on the table at x equals -3 and see if the tables match for the two equations. And then go to x equals +3 and see if the tables match. And that's how you're going to determine if it's choice 1 or 3. Similarly, for this one, you see that x cannot equal the value of 2, and x cannot equal 6, because if it does, they will be excluded. So based on that, I can eliminate choice 1 before I even do anything, because 6 cannot be in the domain. All right, let's move on to the next thing. You know you're going to see something where they're asking for the value that makes these two equal. This is actually a system of equations. Basically, you put the one side again in y1, other side in y2, and then you would look for the intersection. You could look on the table, but the table's not going to help you really with this because the answers are to the nearest hundredth, it looks like. So you're actually going to have to find the intersection. So I always recommend that you do zoom 6 to start, and then just kind of play around with your window to try to find the intersection points. I know some people use zoom fit. I just kind of use common sense, but if you see one intersection, you're going to go down to the only answer with one intersection, which is choice 4. If you see two intersections, you're going to be down to the others. If you see no intersection, something is wrong because there's none that have no intersection, etc. If you see one like number 2, where it's not in y equals form, this one is in y equals form, so I put this one in y1, but this one isn't. I have to get y by itself before I can put it in y equals. So I'm going to divide by x here. I'm going to get y equals 20 over x, and now I can put this in y2. And if you can't find that on the calculator screen, you may have to zoom out. So just remember, zoom out also works. And just hit zoom out and then enter, and that's how it works to see the points of intersection. Now, don't quote me on this, but I only predict you're going to have one parabola question. So I think you're either going to have one multiple choice or one quick two-pointer. That's what I predict. So if you are very bad at this topic, the good news is you're only going to lose 2 points. But my best advice is always sketch whatever you can, because if you don't sketch, how are you really going to visualize this, right, people? All right, so for example, you know that it's always going to be DVF or FVD. You know the vertex is always in the middle, okay? So this first one gives you a focus of 4, -3. So I would sketch it 4, -3. Put a dot and label it F. Gives you a directrix of y equals 1. So go to the y-axis, go to 1. Label it D for directrix. Then you know the vertex has to be in between the focus and the directrix. It has to be the midpoint. So find the midpoint between 1 and -3. There's 4 total units. So if you went 2 units up or 2 units down, you're going to get the vertex, okay? Now, when you draw it, remember, you draw it from the vertex, and the focus is always inside the parabola. So this one is going down. If something is going down, then it's going to be negative, okay? Negative x squared specifically. So if you look at these choices, you see, if you look at the coefficients here, 2 of them have negatives, -8. The other 2 have positives. So I'm going to cross out choice 1 and 3. I didn't even do much work here, and I'm already down to 2 choices. Now, the next thing you need to know is you always care about your vertex, and you change the signs if the vertex is in parentheses. So this is going to be 4 comma -1 for the vertex. So if you see here, it's got to be choice 4 because the other one doesn't even have the vertex in there. It looks like they're using the focus, so it's out. Always use your vertex in your equation, not your focus. So based on that, it's choice 4, and notice the signs changed because both of them were in parentheses, so both signs had to change. So for this next one, you see the vertex is 2, 1, the focus is 2, -3. I labeled them both. Before I even do anything, I noticed that this one has a different format for its equation. This is called vertex form. So again, you have to know the vertex is going to be in the equation. So you know they're going to be using 2, 1. Okay, so keep that in mind. And the format is y equals 1 over 4p x minus h squared plus k, where h comma k is the vertex. So basically, you know they're going to use 2, 1. The x minus h is going to be x minus 2 because that's in parentheses, it's going to change sign. And then the plus 1 is going to remain the same. So based on that, I already know that it's going to be not choice 2 because that's got plus minus. They could change the sign of the 1. Minus plus, that's going to be okay. And this is the wrong one, so that's out. So already I'm down to 1 and 3. So now here's where it comes down to visualizing it. You know it's DVF or FVD. So we have FVD. So again, the directions has to be up top somewhere. So is this going to open up or down? I'm hoping you're going to say down because again, it goes from the vertex as the turning point and then it goes toward the focus. So if you know it's going to go down, it's going to, again, it's going to be a negative, and negative is going to be choice 3. So again, x minus 2 plus 1. Okay. So same thing here. You're just going to sketch it and you'll get your answer. Just sketch it. Make sure you sketch it. If it's free response, you really have to sketch it to show a little work. All right. Now, you know they're going to ask one question. You know it, where they ask for a recursive form. So remember, recursive has 2 parts. The 2 parts are made up of this first term, A1, initial term, and then they're also going to ask you about something involving the previous term, which is called A sub n minus 1. So if you're at AN, the one before you is called AN minus 1. So if you know that there's 2 parts, you know you could eliminate choice 3 and choice 1. Isn't that exciting? And then also this is algebra 2, and you know that it's going to be geometric in algebra 2, and you know that there's going to be a common ratio, and you know that you're either going to be multiplying or dividing. So you know the answer has to be choice 4 because choice 2 is subtracting, and subtracting is arithmetic. So it's probably not going to be 2. But if I wanted to get the common ratio R, I would take any term and divide by the term before it. So 48 divided by 64 should equal the same answer as 36 divided by 48, which is 0.75. That is the common ratio. Notice this is going down, 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 down over time. That's called decay. So that means that 75% remains, which means 25% decays, if this were a word problem. All right, now let's get to graphing. So you guys, there's going to be a graphing question, but do we know what it's going to be exactly? We do not. So we know it's probably going to be 4 points, okay? That's number 1, or 6, but probably 4. Secondly, they're going to ask you either they're going to make an exponential graph, which is this one, or a log graph, or a polynomial graph, or maybe a trig graph, but it's going to be 4 points. So the first thing to know is if they say graph, you're going to put arrows on your graph. If they say over a restricted domain, then you don't put arrows on your graph. So there is no restricted domain here. Thus, we will put arrows on our graph. What you're going to do is go to y equals, you're going to type this into y1, and then you're going to copy down a table. I do highly recommend you copy down a table. The people who are like, why do I have to copy down a table? Just do it, okay? How many points? It's up to you. I like about 5 points, -2, -1, 0, 1, 2. Maybe do a little more than that. Pick some that are nice points, okay? And copy those down. Why? You have 3 hours. Just freaking copy down the table, please. Now, Please note that when you do a graph, you need to show some kind of scale on the axis. So what are you counting by? Are you counting by ones? Are you counting by twos, fives, etc.? So make sure you put that scale in all the way around if you can. Now, if it is an exponential or a log, we want you to graph the asymptote. So the asymptote in this case is y equals 2 because this was shifted up 2 units in the y direction. So I will put that in right away. And that is going to be a dotted line. The calculator is not capable of graphing the asymptote for you, but if you look on the table, it's going to be where you see the first error message. So it will say error at 2. It will also say error at, not at x equals 2. I apologize. That's not a good way to do it for this. Only for the log, you can do that. All right, so now the next thing to note is the graph. The calculator is not capable of showing what's really happening around the asymptote. You kind of have to know it. So after you copy down your points, you have to figure out what's the behavior around the asymptote because the calculator kind of just makes it stop. It won't show arrows on the calculator. So here are some points. I added some more points in. And I'm going to graph these nice points if I can. So I'm going to graph 2, 1. That's a nice one. I'm going to graph 3, -1. That's a really nice one. 4, -7. Great. And then what's going to happen is I'm going to try to graph a few of these around the asymptote. So 1, 1.6. Okay. 0, 1.8. All right. Now I'm getting really close. Okay. Now what you're going to notice is the calculator is not going to show everything that's happening. It's just going to show it going like this, and then it's going to kind of stop here. You have to understand that this is going down forever, so you're going to put arrows on the graph, and it's also going to approach touch the asymptote. Do not cross over the asymptote. Put an arrow on it like it's going alongside it. At the end of your graphing time, I want you to check, did you label your axes if they're not labeled? These were labeled. Do you have numbers on your axes that you scaled number? Do you have a table? Do you have arrows on the graph if you need arrows, okay? I'm not going to do this next one with you fully, but I just want you to note that this one has what we call a restricted domain. So restricted domain means that you're only graphing from x equals 0 to x equals 3, just like we did restricted domain when we did our average rate of change. So you're gonna put this in y equals, okay, the whole thing. Then you're just gonna copy down 0, 1, 2, and 3 for the x values, and you're gonna just write down those values, and then you are not going to put arrows on your graph. Very important. You're just gonna put endpoints, okay? And then you're gonna, when you do your graph, you're gonna make sure that you make it smooth. So this is a polynomial, and if you were to multiply x times x times x here, this is going to be x to the third. Specifically, it's going to be negative x to the third, which is a negative odd cubic polynomial. So make sure it looks smooth, because remember, a polynomial is going to look either like this or like this, right? And then what I recommend you do is you go to your window after you put this in y equals, and you make your window match whatever this picture is. So make your x minimum 0, make your x maximum 3, make your y minimum 0, and then make your y max whatever you think, okay? And then down below it says, what is the max? So I just want to remind you there is a function on your calculator for this. To get it, what you have to do is press second trace, and then you go to the one that says max, which is number 4. And then what you do is you move your cursor to the left of the maxima, which is the turning point, by the way. Left bound, hit enter. Right bound, hit enter. And then you hit enter again one more time. So you're really hitting enter 3 times, because you're going to scroll to the left, hit enter, scroll to the right, hit enter, and then hit enter one more time, and you'll get your maximum. And they specifically want the y value of the maximum, because they said the maximum volume. If you go back to the question, the volume is the v of x, which is the y. So pay attention to notation when you're doing your Regents, because just keep in mind, sometimes they ask for time, which would be x, and sometimes they ask for f of x, which is in this case volume. Also, you need to know this notation. This is called end behavior notation. So if you see something that says as x and then an arrow, remember this means approaches. Specifically as x approaches negative infinity. So as you look to the left on your x-axis toward negative infinity, this is the x-axis, where is the graph going? So if you put this in y equals, I recommend, then look at it and see what's going on as you look to the left. I'm hoping you're going to see that it's approaching the asymptote of 2. Now we have a log. You can do the same thing. Put it in y equals and take a look. And then go through the choices and see what you get. The next thing we're going to talk about is another 4-pointer or 6-pointer. This is going to be a 4-pointer, and this is probably going to be a long radical equation. So you need to know how to solve a radical equation. All right, so first step you guys need to know is isolate the radical. You know what? Let's add a step. The first step is going to be do the calculator strategy to find the intersection and get the answer before you even do anything. So put this in y1, put this in y2, find the intersection and write it down, okay? When you write it down, I think you get 4. Now, just write that on the side, note to self, all right? And you could even sketch it, sketch the little intersection for yourself and be like, okay, I know I have to get 4. Now what we're going to do is isolate the radical, so -5, subtract 5. You cannot square both sides until you isolated the radical. Once that radical is isolated, now you can square both sides, which is the opposite operation of the square root. Now when you square both sides, the square and the square root cancel each other out, and you just get what's under the radical on the left. Now on the right, here's where you know you're going to have to do box method or FOIL. And this is where kids mess up a little bit. They forget how to do that. So on the side, you're going to do 2x minus 5 times 2x minus 5. Here's where it gets kind of algebraic. All right. After you do that, then you want to move everything over to one side of the equal sign. Okay, so I just want to remind you what we did first. First, we got the radical by itself by subtracting 5. Now the next thing we did was square both sides because it was a square root. If it were a cube root, we would have cubed both sides. Then we start to square the binomial because you know you're going to get a binomial. So you know you're going to have to do box method on the one side, which is what I did in my head. And then you're going to move everything to one side, set it equal to 0 into standard form. And then you're going to factor or do quadratic formula if you're not good at factoring. You know that if it's a long one, they're probably going to make you do A times C factoring where you make it into 4 terms. All right, so now next thing we're going to do is subtract 49 to the other side. We're going to add 10x, and then we're going to try to factor this out. Okay, so this was the quadratic that I got. I just want to make a note about this. You know the answer is going to be x equals 4, right? So eventually what you can do if you're not good at factoring is note that if x equals 4 is the answer, one of your factors has to be x minus 4. So keep that in mind down here when I get to my factoring step. So now I did a GCF of 2. I put it on the outside. I didn't drop it yet. Then I did A times C, and I got 2 times -12, which is -24. And I thought about the factors of -24 that multiply to -24 and add up to -5. So I got -8 and 3, broke that down, did grouping. I ended up getting x minus 4 as one of my factors, which is what I was saying to you guys. And then you tee it off, and you reject the 2 because 2 does not equal 0. You get -3 halves, and you get 4. But remember, if you did this from the beginning, there was only one intersection from the beginning, and that was at x equals 4. So that means you have to reject this other one. So you got to be really careful with these. These are long. Look at how much work I did. A lot of work. It's not necessarily hard, but it's a lot of work. Now, another 4-pointer we might predict is a system of equations. So you might get, this is actually a conic linear, but this is a line and a parabola, which I think is easier, to be honest, than a circle and a line. If they're both equal to y, it's pretty straightforward. You just have to set them equal to each other because they both equal y. So you just set them equal to each other, and then you would move everything to one side and you solve for x, and then eventually you solve for y. So a key thing about a system you need to know is you need x and y. So let's say you get x comma something, you have to actually plug in and solve for y. So your answer is probably going to be 2 points of intersection with x's and y's, right? You need the y's, very important. Now, very, very common on the Regents are questions about polynomials. They're probably going to ask you a few multiple choice questions involving polynomial behavior. So there might be something about the end behavior, and there might be something about the roots. So this first one talks about which is a quadratic with imaginary roots, okay? Another name for zeros is roots. If there are imaginary roots, that means that it doesn't cross the x-axis at all. If you know that you're down to choice 3 or 2 because they both are floating either above or below the axis. But quadratic, what does it mean? It means there are 2 roots because quadratic is x squared. So that means you're looking for a parabola. Which one is a parabola? Choice 2 or choice 3? I'm hoping you're saying choice 2. So that's why this other one is out. If they ask you which equation has imaginary roots, again, you just got to put them all in y equals, and you need to look for which one does not cross the x-axis. There may be more than one, though. So if there's more than one, you have to plug in for x, plug in 3 plus I in for x, and see what you get, and plug in 3 minus I, and see which one will yield 0. So what do I mean by that? Let's say I was doing choice 1, x squared minus 6x plus 10 equals 0. I would plug in 3 minus I squared minus 6, 3 minus I plus 10, and see in the home screen if it equals 0. And if it does, that's going to be one that works. Now, very likely is that they ask you something about the type of root and the end behavior. This one's a little more abstract. If you look, they all have A's and B's, so keep that in mind. It's like a little scarier to look at. But it says cubic polynomial, so that means 3 roots total. Cubic means x to the third, which is odd degree. It says only one real root. So if there's one real root, that has to mean that there's 2 imaginary roots because they have to total up to the degree, which is 3, okay? And it says as x approaches positive infinity, so as you look to the right, f of x goes to negative infinity. So then it means the graph's pointing down. So down to the right, that means up to the left. Down to the right, up to the left. So keep that in mind. That means that's actually a negative odd. Negative odd, okay? So now if you look at these, we can actually start eliminating because some of them are not even odd. This is x times x squared is x to the third, but it's positive, so it's out. We're looking for a negative x to the third. This is negative x times x squared, that's negative x cubed, it's still in. This is negative x squared and x squared, that's negative x to the fourth, out because that's even. And this is x times negative x squared, that's negative x cubed, it's still in. So we're already down to choice 2 and 4. Now go back to where it said there's only one real root, okay? If these had been numbers, let A equal 2, let B equal 3. Which one will give 1 real and 2 imaginary, right? So I'm going to erase this for a second. Erase that for a second. Let's put in our values that we just picked. Okay, let A equal 2, let B equal 3. If we were to solve, we could actually put these in to y equals and see which one works, by the way. That's one way to do it. Or you could solve. If you solve, you would set it equal to 0. You would get x equals 2, and then you know what you would get over here? You would x squared equals a negative number. When you square root, you know what you get? Imaginary. So this is going to be the answer, choice 2. If you were to do this one, you will get x equals 2 as well, but then you get 3 equals x squared. You're going to get irrational but real. Plus or minus radical 3. This would have been plus or minus radical negative 3. So the answer is choice 2. I say graph it. Next thing you're going to get is definitely a bunch of wordy questions involving experimental design, sampling, something like that. So here's the main things you need to know. If they're asking about a sample, you want the most random sample. The most random sample is going to be the least biased sample. That's important to note. So they might say which of the following is true, something like that. The other thing that another important thing that they like to ask about is the difference between an observational study and an experiment. So only an experiment can establish causation, which is called cause and effect. So if I'm investigating if a treatment works, only an experiment can establish cause and effect, but an observational study cannot. So whenever you get a multiple choice question that says which of the following is true, it's annoying because you have to read all the choices, or if it said which of the following is not true. So keep that in mind. This one says a survey about parenting styles given to every 10 student entering the library will be giving unbiased results. You can't ask people who are students who enter the library about parenting because not everyone enters the library. So that actually is biased because you're not including the kids who are not at the library. An observational study allows a researcher to determine cause and effect. That's not true. An observational study is merely observing and just kind of analyzing what you see, but you're not giving treatments to those involved. So you cannot establish causation. You can only establish correlation. Only in an experiment we can establish causation. So 2 is out. Margin of error increases as sample size increases. This is false. As the sample size increases, margin of error decreases. So the answer should be 4. A survey collected from a random sample can be used to represent the opinions of the school. So if I took a random sample of students from the school, it should be able to represent students from the school. So the sample should be taken directly from the population of interest. Okay, so number 2 is similar. Just read it, make a choice. Now, will there be factoring on this test? I say yes, there will be some kind of factoring. I think it'll probably be a 2-point question, a 2-pointer that is open-ended. Basically, if you do anything right on these 2-pointers, you'll get a point. And if you do anything wrong, you'll get a point. So usually they're going to say something like factor completely, okay? So factoring completely means more than one step. So if you have 3 terms, 1, 2, 3, it's going to be trinomial. In trinomial, it means you're going to do the AM method, which means you multiply to the last term, which is positive 4. So 1 times 4 is 4, but you have to add up to a negative. So you're going to do, instead of doing x times x here, you're going to do x squared, minus 1, minus 4. All right, and then here comes the factor completely part. You're going to do dots. So you're going to do x plus 1, x minus 1, x plus 2, x minus 2 for 4 total factors. So the hardest part was realizing that this is really not that bad to do. It would be like treating it as x squared minus 5x plus 4. You guys would know how to solve that one. So just know if it's x times x, it's x squared, but x squared times x squared is x to the 4th. Now the next question says algebraically determine the zeros. So first you need to know that if you do it graphically, you get half credit. So that's better than nothing. So I kind of recommend you start with graphically. First do it graphically and write down the answers to where it crosses the x-axis. These are called the x-intercepts. So look for where it crosses the x-axis, or look for where the y values equal 0, where y equals 0. And write them down. And then you're going to do it algebraically. So algebraically, you want to set it equal to 0, hence the name zeros. And then you want to try to factor to solve. So remember, if you have 4 terms, you're going to do factoring by grouping, okay? So group the first 2 terms together, do the GCF, second 2 terms, do the GCF, solve it out, and then check it graphically and see what you get. Another thing that I put money on is going to be on this test is they're going to give you one with an I involved where you have to either do it out by hand or you could plug in a value. So if you look at number 1, all right, we could do this by hand. If you did it by hand, you would do x minus 2y times x minus 2y using the box method, all right? But it could get a little ugly. So another multiple choice strategy that you can do is pick a value for x. Let x equal 3, for example. Plug that into here, into the original like this. 3 minus 2i squared. Put it in the calculator in the home screen and write down what you get. And then go to all the choices and plug in 3 for x. Write down what you get. And see which one matches, okay? Now, yes, you could do this the real way, which is box method. But the key, if you ever get an I value that is greater than 1, like I squared, for example, you're going to have to change I squared to -1. So just keep in mind, it gets a little ugly if you do this by hand. For the second one, I tried to do it by hand, and then I realized that it got kind of ugly. So another option is you can plug in the answers for K. So you would go to each one, plug in the values in for K, like -36, for example, and see what you get and solve it out. So there's plenty of calculator strategies for multiple choice. Now, there could be some other things on the test that are a little less predictable. We know there's going to be some kind of multiple choice question at least where there is something having to do with exponential rates. There may be more than one. So there might be one about the basic exponential function like this, where it's ny equals ab to the x form. And they ask you something about, is it growing or decaying and by how much? I think this one is very basic and may actually be easier than what you're going to see. So this is decay because the growth factor, which is 0.84, is less than 1. So this is decay. So you know you're down to one that says decreases. And then remember that if the number is less than 1, if you set it equal to 1 plus the rate, if you were to solve for the growth rate, you're going to get not 84%, you're actually going to get 16%. So this means that 84% is what remains, but 16% is what decays. Now, it's important to keep an eye out for what the T stands for. This is T years, so T is in years. So that means that once a year, it's going to be decreasing by 16%, okay? Just keep in mind, it could be in terms of years, days, months, etc. So now you're definitely going to get one where they ask you for an equivalent function. So you can technically use the y1, y2 method, where you put one in y1, the other in y2, and see if it graphs on top of itself or approximately, because this is approximately. But where they give you, in this case, the annual rate, because they're saying that x is in years. So this is the annual equation, which means the annual growth rate is 0.0325 or 3.25% growth per year. And then they say, can you convert it to monthly, basically, okay? So this is where you need to know that if it were monthly, the exponent would be 12t or 12x, because that means 12 times a year. So if you know that, you're already down to choice 1 or 3. So now what you do is you realize that if it's 3.25% per year, it cannot be 3.25% per month, so it's not choice 3. The answer is going to be choice 1 without me doing any math. But mathematically, we went over, it's got to be the base to the 12t, this base, has to equal whatever the old base was, 1.0325 to the 1t, or x. You could use x or t. So basically, the 1t means annual, and the 12t means monthly. So you take your base and you raise it to the 12th, and you set it equal to the 1.0325. And then to solve algebraically would be to raise both sides to the reciprocal exponent, which is 1/12. And that's actually how you're going to get b equal to 1.027. So if that's confusing to you, I do recommend that you just put 1 in y1, 1 in y2, see if it graphs on top of itself, or you could plug in a value for x and see if it makes sense logically. Now, you know you're going to get a question involving half-life or doubling time. So this is half-life because notice it has a base of 0.5. So the half-life equation is not one that is on the reference sheet. You have to memorize this. So I'm going to start. It is amount equals initial amount times half for half-life, t over h, where h is the half-life and t is the time elapsed. A sub 0 is the initial amount. So it says which of the following is false. Okay, so again, it's annoying because you have to read all the choices. So first thing is the initial amount would go here, which is 50. In this case, grams, and that would be at time t equals 0 days, okay? So this says in 20 days, there's no substance remaining. So if you plugged in t equals 20 for 20 days, will you get 0? And the answer is going to be no, because if you plug in 20, you're not going to get 0. You're actually never going to get 0, because remember, if something's halving on itself over and over again, it's actually never going to really reach 0. It's just going to be very, very, very tiny, but not 0. Okay, number 2. After 2 half-lives, there's 25% remaining. So 2 half-lives would mean you have to know what the half-life is, okay? So remember, it's t over h. The denominator of the little fraction is the half-life. So the h here is 3. There's a little 3 here, okay? So 2 half-lives would mean 6 days. So 6 days means you have to plug in 6, a of 6. So if you plug in 6, is there 25% of the substance remaining? I think this winds up being the answer because you wind up getting 25% of 50 remaining. 3, the amount of the substance. Oh, it says which is false. Oh, it says which is false. Whoops, I already messed up one of my rules. You got to go back and read the question. And the question says which is false. So the answer is choice 1. Choice 1 is false. So the rest have to be true. Choice 3, the amount of the substance remaining can also be written as this. This is also true. This is true. Because remember, if you have 1/2 as the base to the t over 3, the reciprocal 1/2 is 2 to the negative 1 to the t over 3. So that's actually true as well. That's just a law of exponents. And the last one, after 1 week. So think about 1 week is how many days? 7 days. If you plug in 7, what will you get? And it should be less than 10. I think it's around 9. Okay, so there you go. Those are kind of tricky because you have to work every single choice out. What a pain in the butt. Similarly here, this is equivalent. So again, you could put 1 in y1, 1 in y2, but the problem is you don't have an a sub 0 here. So you could pick a value for a sub 0. Let a sub 0 equal 100 or something like that. Or maybe make something easy like 1. And then see if they're equivalent. They graph on top of itself. Otherwise, you would have to, you want it to equal 1t here. And right now it's not 1t. It's actually t over 0.0803. So what you could do to get just 1t in the exponent is just take 1 over 0.0803 and raise 0.5 to that and see what you get. It should be choice 1. Okay, are you going to have inverse on the Regents? I think you are, but I'm not positive on this compared to the other ones like average rate of change and all those where I was very confident. This one I said maybe you may have a multiple choice where they're asking you to find the inverse. So what do you need to know about this? The original is f of x. The inverse is called f negative 1 of x, and that's a notation. To find the inverse, it's a reflection in the line y equals x. The point switch, so xy becomes yx. And to find the inverse algebraically, you switch x and y, solve for y. Switch x and y, solve for y. So in this first one, you could do it algebraically. Another trick you could do is look for reflection over line y equals x. So put this in y equals and y1, put the choices in y2, and see which one has symmetry over that line y equals x, or see if the points switch positions. Same with choice 2. You can do number 2 as well. Now, trig, we actually never know what the trig is going to be on. It's very unpredictable. So some examples we've seen lately have been something having to do with that bow tie triangle. So here is a bow tie. If you're drawing a triangle that looks like a bow tie, you're doing the right thing, but you have to know what quadrant you're in. So this says cosine is positive. It doesn't say it, but you need to know that this is a positive. So cosine is positive, and tan is less than 0, meaning negative. So cosine is positive, tan is negative. So x is cosine is positive, so that means x is positive, and that's in quadrants 1 or 4. And it says tangent is negative, so tangent is negative means we're in quadrant 4. So first thing you need to know is what quadrant we're in, okay? That's half the battle. This means cosine is positive, tan is negative, cosine is positive. Now what you're going to do is draw a triangle as a part of the bow tie like this, coming out from the origin, perpendicular to the x-axis. You can create a point here and a point here and just connect them to make your hypotenuse. Okay, this is going to be angle A. According to SOHCAHTOA, cosine is adjacent over hypotenuse. So the adjacent side is going to be radical 5, hypotenuse 3. So this is not a 3, 4, 5. Do not assume it's a 3, 4, 5. It would only be a 3, 4, 5 if the hypotenuse was 5. So this, you have to find the third side using Pythagorean theorem first, and then you can find sine, which is opposite over hypotenuse. Okay, so SOHCAHTOA. All right, so you're going to do a squared plus b squared equals hypotenuse squared. 5 plus x squared equals 9. Solve for x. Remember, when you take the square root, you're going to have a positive or a negative answer. And because this is going down, this is going to be a negative. So this is actually going to be negative 2. Negative 2 here. So then the sign is going to be opposite, which is negative 2, over hypotenuse, which is 3. There you go. Okay, so you try this one. But note with this one, this says cotan. So you need to know the trig reciprocals. Cotan is the reciprocal of tan. So tan would be the reciprocal of this. So cotan is negative 3 over 1. That means tan is 1 over negative 3. Now try this question using the same kind of bow tie concepts that I did in number 1. Okay, will exponential regression be on it? I don't know. It was on 1 recently, so maybe 1 to 2 recently. So let's go over how to do this. First, you're going to press Stat, and you're going to go to number 1, which is Edit. And you're going to enter the data in L1 and L2. So in L1, you're going to put in the X values, and in L2, you're going to put in the Y values. Okay, just like that. Hit Stat, Edit, enter them in. Once that's in there, then you're going to press Stat, go over to Calc, and you're going to go down to number 0, which says Exponential Regression. Make sure it says L1 and L2, nothing in the frequency list, and then when you write your answer, you're going to round appropriately. Remember, the equation for an exponential is y equals ab to the x. You're going to plug in a and b, and you're going to round to the nearest thousandth, which is 3 decimal places. Will trig graphing be on the Regents? I think you're going to get 1 multiple choice about trig graphing. Do I think you're going to be asked to graph? I don't know. So it is important to know the basic equation of the trig graph, which is the amplitude is the number in the front, then the frequency, then the horizontal shift, and then the midline. So AF, HM stands for amplitude, frequency, horizontal shift, midline. So if they're asking for the amplitude, it's just the number in front, 4.8. If they're asking for the frequency, it would be the pi over 6. The horizontal shift is to the left 3, and then the midline is y equals 5.1. If they wanted us to find the period is not on here, but it is 2 pi over the frequency. So I would have done 2 pi over 6. And if I do keep, change, flip, this becomes 12 for the period. So just keep in mind, they might ask you for that period. They might ask you for the maximum, which is midline plus amplitude. They might ask you for the minimum, which is midline minus amplitude. They might ask you for the range, which is maximum to minimum. What else? I feel like that's it. So here is a question that's a little harder. It has shown up on the last couple of Regents, so maybe you'll get one like this. They're asking for what is the function doing over this interval? So first, I would recommend sketching whatever you can, okay? So the amplitude is 3. There is no midline, which means the midline is 0. There's no midline in the back, right? So you're going to go up 3, down to -3. Sine curve starts at the midline, so it starts at 0. And the period is 2 pi over the frequency, which is 1/2. 2 pi over 1/2 is equal to 2 pi times 2 over 1, so 4 pi. And the quarter points are period divided by 4. So if you did 4 pi over 4, you're going to get pi. So that means we're counting by pi's. So we're counting 1 pi, 2 pi, 3 pi, 4 pi. That would be one curve. And then if we were to go backwards, we would go to negative pi. So this is asking, what is this function doing over the interval from negative pi to pi? So you could put this in y equals, and you could type in the window x min negative pi and x max positive pi, and then try to find it. But if you know the concept of the sine curve starts at the midline and then it goes up to the maximum, I would have stopped here. And then if I had backed it up the other way, it would have gone down to the minimum here. So this would have been the interval that you were interested in. From negative pi to pi, it's going up or increasing because there's a positive slope. So it just increases the whole way. Now, if they do ask you to graph, this will probably be 4 points. So I recommend that you write the amplitude, frequency, midline on the side and list everything you know. The amplitude is 2, the frequency is 1/2, the midline is y equals 5. Then I would go to your grid and I would just, with pencil, please graph in pencil, I would number. Remember, you have to show a scale, very important. So I would now go to 5 and do a dotted line. That's the midline. And then you're going to go up and down by your amplitude. So up 2 and down 2 of 5. 5 plus 2 is 7. 5 minus 2 is 3. So the minimum is going to be 3, the midline 5, and the maximum is 7. The period is 2 pi over the frequency. So 2 pi over 1/2 is equal to 2 pi times 2 over 1, which is 4 pi. And the quarter points are period divided by 4, which is 4 pi over 4, which is 5. So notice this is called a restricted domain. So they only want you to go from 0 to 2 pi. So on my x-axis, I'm going to go 0, and then I'm going to go to 1, 2, 3, 4, 5. We go to pi, 1, 2, 3, 4, 5, and then 2 pi. And they only want me to go 2 pi. So remember, the quarter points are by pi. So it's going to be 1 pi, 2 pi, 3 pi, 4 pi. If I saw a whole curve, this is a cosine curve. Cosine starts at the maximum, positive maximum. So we're going to go up to the 7. Then we're going to hit the midline at 5. And then we're going to go down to the minimum. And then technically, I'm done because I'm only going to see 1/2 of a curve in a 2 pi interval. And that's what the frequency tells us, doesn't it? There it is. Will you see one of these? I say maybe one multiple choice, one sole multiple choice. Do you really want to do it by hand? Nah, probably not. I would maybe use a calculator strategy. So you could let x equal a number, let y equal a number, plug it in, plug it in. That's kind of annoying. Some of you are going to see that you could do this by hand. Some of you might also see that this is actually factoring in disguise. So believe it or not, this is actually x squared plus y squared. This is actually perfect cubes because this is the cube root of x to the 6 is x squared. And then you square, multiply, square. So what they did was they went to choice 1 and they did a little grouping situation here where if you group this and this together, that makes this. And then the remainder on the outside would be x squared plus y squared. So it actually was choice 1. I just thought it was kind of mean to look at. So number 2, same kind of thing. Those are kind of scary. I recommend you skip them at first if you're scared. Now, will you see laws of exponents? You will in some form. Will it be a quick multiple choice or a 2-pointer? I think they're moving to these harder 2-pointers down here. This one's pretty easy. Power over root. You need to know the flower is the power that goes above the ground, and then the root goes under the ground. So the power is the 3, and then the number that goes in the root is going to be the 4. Power over root, that's called an index. Okay, so that's pretty straightforward. Now it said equivalent, right? So couldn't you have put this in y1 and put the choices in y2? You could. But now, what if you get one of these? Now you actually have to do some math here, people, because I want you to do it algebraically. So if you pick a value for x, that's not really going to work for you. You have to know the laws of exponents. So first, when you divide, you subtract. So you're going to do 17/8 minus 5/4, okay? Whatever you get, you will write it here. After you do that, it's being raised to the -4th. So you need to know that whatever you get here, you're going to multiply. So do 17/8 minus 5/4, whatever you get, put it here, and then multiply. And then it says equals y to the n. So whatever you got is going to equal y to the n. So you would drop the y's and you would just set n equal to whatever you got. Okay, for this one, number 3, you have to know that this is a power over root situation. So this is really 81 to the first. So this is 81 to the 1/3, x to the 15/3, and y to the 9th. If you were to simplify this, you get x to the 5th, y to the, 9/3, which is 3. So these two check out, okay? It's just the 3 that's the problem. So how can you rewrite 3 to what power equals 81, basically, and then bring the 1/3 to the outside? So 3 actually to the 4th is 81. So if you put a 4th here, then what you're going to do to get the 3 to the power is you're going to multiply, because when you raise a power to a power, you multiply. So you have 3 to the 4/3 equals 3 to the a. Once you have the same base, you drop the base, and you could set the a exponents equal to each other. Last but not least, what's going to be the 6-pointer? I predict it's either going to be a crazy graphing question or a crazy long word problem question. And at the end of it, you're going to have to do logs. You're going to have to do logs, and that's going to suck. Maybe. I actually like logs, but some of you don't. So here is an example that's not that bad. This one's asking about doubling time. So the first thing you need to know is the doubling time formula. You have to memorize. It's like the half-life formula. It is a equals a sub 0 times 1/2 or 2. So this is 2 doubling. T over h or t over d. This is d for doubling. Okay. So let's underline the key information. We're starting with an initial value of 11,000 bacteria. I don't want you to get scared. You guys can do this. And it says write a function, p of t. So instead of using a or y equals, I have to use their notation, p of t. That's something that you should look at the end of your test. Go back and read the question and look at it, okay? It says t is in minutes, so leave t alone. And it says that it's doubling every 20 minutes. That's the doubling time, d. So you're going to do t over 20. All right, and that's that for part A. Is that bad? No. Now, using part A, how long will it take to reach 1 million bacteria? So you're going to plug in 1 million in on the left-hand side. This probably was a 4-pointer, not a 6-pointer. It seems too easy. And now we're going to solve it algebraically. Now, could you have solved it graphically? Yes. You could put one side in y1, other side in y2, look for the intersection. You will get half credit. Algebraically, here are my tips. First, isolate the base. So divide by the coefficient of 11,000. If it is not a nice number, you're just going to leave it exactly how it is. 1 million over 11,000 equals 2 to the whatever. Once it's in this form, you're going to change it to a log. How do I know? Because I can't do it in any other way. So remember, it's log base, answer, exponent. So you're going to keep the base, which is base 2. Keep the base. The answer that it equaled was this crazy thing. So that's going to go in here, 1 million over 11,000 equals the exponent t over 20. And then to get the t by itself, you're going to multiply both sides by 20 over 1. And you will get your answer. Just put in the calculator. Now, let's say you get a mortgage question or one like this where you have like a crazier looking equation. I don't want you to panic because you can do this. It's just a lot of words. You just have to read what everything stands for, underline the key information, and then substitute. So they have an initial temperature is the sub-zero, a room temperature, a rate, and time, and all this good stuff. So they're talking about a temperature of a t-shirt, and they're saying Mark starts the t-shirt at 400 degrees Fahrenheit. That's going to be the initial amount, T sub-zero. They're saying the rate of cooling, R, is this, 0.0735. And the room temperature, which is going to be this one, T of R, equals this. So first it says write an equation. So again, another tip is just read the question. If it says write an equation, you leave it in terms of the variables they give you, okay? So the equation is T equals, so you have to use this equation here. T equals T sub-zero, initial amount 400, minus the room temp, which we said was 75. We could probably clean this up a little in a second. E to the negative R, so the rate they gave me was 0.0735, but because it's cooling, it's negative, right, people? Yeah. The T is the time. They didn't tell me that yet. And then plus the room temperature again, 75. So technically, you are done with part A here. If you just leave it in terms of T, this is a T. My thing is in the way, sorry. There we go. Anyway, so basically there you have it. That is part A done, right? Not too bad. Move this over. Okay. Now that's an equation. So just remember that's an equation. You could have cleaned this up also. Then it says using this equation, find the temperature of the shirt after 5 minutes. So you're just going to plug in little t equals 5 into here. Okay, so you just use the same equation, plug in, put in the calculator, solve. Now it says at the same time, his friend Janine removes a hoodie, and the hoodie's initial value is 450. So that's going to be T sub-zero. And then after 8 minutes, that's going to be lowercase t equals 8 minutes. The hoodie measured 270. That's going to be the final temp. That's going to be capital T. The room temperature, still T of R. Determine the rate. So now they're asking you for R. So basically what you need to know is you're going to use the same equation from above, but you're not going to use the one you used for A for Mark because the hoodie's temperature was initially different than the t-shirt's temperature. So I would rewrite this equation in terms of Janine's information. And this time you're going to solve for the rate, which is R. So you're not going to use the same rate of cooling as Mark. And then lastly, the t-shirt and hoodie are removed at the same time, determine when they're going to be the same. So once you write your equation from part C in terms of Janine's information, then you're going to set them equal to each other. Okay. And then it doesn't say determine algebraically, so you could have done this graphically using y1, y2. And I recommend that with point of intersection. Last one. You may also see a 6-pointer where it involves something involving sequences, specifically geometric sequences, because remember we're in Algebra 2. So we have to worry about geometric sequences and how it ties into an exponential function. So here is what we call, again, a recursive formula. Remember, it has 2 parts. The 2 parts are the initial value, which they're using A sub-0 instead of A sub-1 because they're doing population since 1910. So basically, in the year T equals 0 since 1910, you're in 1910. The initial population was 92.2 million because it's in millions of people. So keep that in mind. And then it's growing specifically by multiplying by this growth factor. So the first thing you should do is take your growth factor, which is what you're multiplying by, and realize this equals 1 plus the rate. So this is equal to 1.015. So which means 1 plus the rate would be 1.5% growth per year since 1910. Okay, so keep that in mind. So it says write an exponential function p, where p of t represents the United States since there. So basically you need to know the basic equation is y equals ab dx for initial value times growth factor for exponential function. But you have to use their notation, so don't use y, use p of t. Initial value is 92.2, 1.015 is the base, and then instead of using x, you have to use t. So that's the first part. And then it says determine algebraically, using your model from before, how long it takes to reach 300 million people. So you have to use logs, okay, to get full credit. But if you don't use logs, just do it using graphing and you'll get half credit. So you said 300 on this side equal to 92.2. Okay, and then eventually we're going to solve this using logs. So what you would do first, again, is divide both sides by the 92.2. Leave it if it's not a nice number. And then you're going to change it to a log. Base, answer, exponent. Okay, so you do that and round appropriately at the very end, round appropriately. All right, if I missed anything in this video, it just means that they're less common, but sure, you could get something that I haven't gone over on the test, like compound interest. I didn't go over compound interest with you on here. So I do want to mention if they say compounded monthly or something like that, you have to know the formula is principal 1 plus r over n to the nt. If it's continuous, you have to know that it's PERT, A equals PERT or B equals PERT, whatever. You know, a couple other things that might show up that are not on here. So please don't take my word as, you know, exactly going to be what's on the test, but these are some predictions based on what we've seen. Okay, so the key things in the beginning of the video where I said are definitely on the test, you want to focus on those, and then you can kind of pick your battles with the rest, and you can use your calculator strategies. Study those formulas that are not on the reference sheet, the compound interest, the continuous interest, study how to go from an exponential to a log, study the confidence interval formula, and study the half-life and doubling time formula. Good luck, and at the end of the 2-3 hours, go back and check your test, read all the italic words, make sure that you round it appropriately. If you're doing a graph, make sure you graph the points, make sure you make a table, make sure you go back and see if you're putting arrows on the graph or not, and really just make sure you answer the question. Reread it and say, did I answer their question? Do not leave anything blank. If it says do something algebraically, do it graphically and get half credit, and draw the picture of the intersection, draw the table, draw anything. Just don't leave it blank. You can do half credit. Good luck, everyone, and I believe in you.